We now turn to construction 21, the centroid of a triangle. This is somewhat similar to the incenter and the circumcenters in that we're going to use the vertices in one case, but also bisect the lines. So what we do here is we look at the line AC. It's quite long, it's 29 in total. So we're looking really at something beyond half of that. So maybe 14, 15 and a half will do it, or 16 will give us some cutoff point. So I'm going to start with C as my center point and construct an arc. And the same from A, using the same radius. And I can see that it crosses in 2 points there. If I join those two together with a construction line, I can find the center point at which AC is subdivided. I'm going to do the same now for BC and bisect it. BC is not as long, looking at about 17, so anything about 8 or more will be fine. I might use a different colour just to show the arcs differently for each line. So 17, anything like 9 would do, 2 9s would be 18, so 9 will do well there. So using a radius slightly more than halfway, and the same from point B, I can find the 2 points of intersection. I can use a construction line, and that can identify the midpoint of BC. Now on this occasion, we don't extend the two construction lines. We found the midpoint of each. What we do is we join the midpoint to the vertex opposite. So using construction lines, and a construction line from here to the vertex opposite to A, I can find the point where they both join, and that's the centroid. The centroid is an interesting part of a triangle because if you think about it, it's the point where if you were to balance the triangle on its head, this side would be the same weight or the same size as the other. Why? Well, because they have the same base. For example, this point here, AD, is the same length as DC by definition because we split it. They have the same base and the same perpendicular height, so they must be then the same area. If they're the same area, you could balance the triangle on that edge. Similarly in here, if you call this point E, BE is the same as EC. These are both the same lengths. And looking at the perpendicular height to A would be the same whether you're coming from BE or from EC. Therefore, you could balance it on this edge. And if everything was perfectly stable and this was hard, plastic or cardboard or something, you could imagine a pin holding the whole thing up if the weight was balanced on all different dimensions. And that's the centroid of a triangle. And that's construction 21.